Hello, algebra class. We're going to get going on another GCF review, but this time we're going to be factoring the GCF out of a polynomial. So that's what we're working on today. Let me know if you had questions from yesterday's lesson. I'm happy to email them or answer them, or we can even try to do that Google Hangouts where I can answer questions if you guys have them. Okay, I'm going to go to the next slide. Okay, remember, factoring means write as a multiplication problem. So this is kind of the going backwards of that double distributive property. So when we did the double distributive property, we ended up at a polynomial. Now we're going to be given that polynomial, and we're going to try to get something out of it. So answers should be written in GCF times, so inside that parenthesis, the leftovers, whatever came out, or whatever was left over after we took out, what was that? Our GCF. So we're going to try that in the next couple problems. So example 1, we have 6v plus 2u. So yesterday we talked about a quicker way of doing this with our variables. We look at the variables and we see if we have anything in common. We see in this first one we have just a v, and there's no v in the second one. So we aren't going to have a v. You see in the other one there's just a u. You see there's no u's in the first one. So we know there's going to be no variables attached. But again, you could go through it. On this one we do that factor tree. So what multiplies to give us 6 is 3 and 2. What multiplies to give us 2 is just 2 and 1. The things in common are going to be the 2's. So we see that our GCF is just going to be 2. So when we factor out that 2, we can write the 2 on the outside, and then it's what's left over. Well, once we take out that 2 here, you already saw that kind of highlighted it. What's not highlighted is that 3v. And then over here, what's not highlighted is that 1u. So when we are writing this or factoring out the greatest common factor, this is what we want to write, like the GCF out front, GCF leftovers. And that is the answer to this problem. I've got a few more for us to try. Okay, this one's a little bit harder to pick out what is our GCF. So we're going to start with the variables again. So GCF. We can start with the x's. You see all of them have x and all of them have y. Remember, we're looking for the one that has the smallest exponent. So on the first x, you see the exponent's 2. On the second x, you don't see it, but the exponent's 1. Third x, the exponent's 2. Well, which one's smaller, 2, 1, or 2? We know that 1's smaller, so x is what goes in here. It's what's in all of them. And then we're going to move on to y. Well, the y's we have here, we have y, 5 to the 5th, to the 5th, to the 4th. So what's smaller, 5, 5, or 4? Well, the 4 is smaller. So we our GCF so far is going to be x, y to the 4th. And then we have to figure out what our coefficients are going to be. So we have 20, so that's 2 and 10. 10 is 2 and 5. Again, if you guys didn't like that method, you could still do that x, x, y, 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 plus. And then over here you have 40, 42 and 20, 2 and 10, 2 and 5. And again, x, y, 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 plus. And then 70, 7 times 10, 2 and 5. Sorry about that. I had messages from other math teachers asking about e-learning stuff. And then again, if you could write these out, x, x, y, 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 y. When we look at this, we want to see what's in common between all of them. Well, we see that there is a 2 in each of them. So we have a 2 here, a 2 here, and a 2 here. That means the 2 has to join up here. And then we have, to look next, we have one more 2, but the third one for 70 does not have a 2 in it, so we know that's not going to work. And then we have a 5. There is a 5 in the other one, so we have a 5 here. Let me switch back to my highlighter. So we have a 5 here, a 5 here, and a 5 here. So 5 is going to have to multiply up here as well. And then I'm going to highlight this just so we can see it. We already decided that there was one x in all of them, so x, x, and x. And that's the most x's we can get because that middle term only has the one x. That's the most restrictive. And then we talked about having 4 y's. So we had 1y, 2y, 3y, 4y, 1y, 2y, 3y, 4y, 1y, 2y, 3y, 4y. And you see that we now have that many in each of them. Going through this, We can confirm that is our GCF. We're going to multiply 2 times 5. Well, 2 times 5 is 10. X, y to the 4th. And then we're going to put what is left over. So what's left over here, I'm going to highlight it in yellow for this first one. We see we have a coefficient of 2. That one was not used. And then we have 1x left. And we have 1y left. And then we're going to go to the next one. So I'm going to put a plus sign there. We have 2 and 2. So to put that in here, we're going to have to multiply them back together. So 2 times 2 is 4. And then we have just 1y remaining here. Plus, and then we have a 7 that's lingering on this last term. And then we have 1x that's still there. Now you guys don't do this part, but I want to make sure that you get a chance to see it. So if we did this again and we multiplied it using the double distributive property, you'd end up with 20, 2 times 10. And then we add our exponents, so 1 and 1. So 1 plus 1 is x squared. Then we add our exponents here, 4 and 1. That gives me 5. We go on to our next one. 10 times 4 is 40. And then there is no x, so we just got to keep it as is. It's just going to be x. And then y to the 4th plus y will be y to the 5th. Plus, and then 10 times 7, that's going to give me 70. X to the 1st plus x is x squared. Y to the, and then there's no y in the last one, so it stays y to the 4th. And if you look, these are the exact same. So we know they're the correct factorization. So we know we factored out the GCF. Ooh, let's go back, let me box that in. So this was your answer. Again, you didn't have to do that bottom part, but I wanted you to see how that works. Let's go on to the next one. Okay, again, let's go do this. So factors of 35 are going to be 3 and 7. So, oh, that's not right. That's 21. It's going to be 5 and 7. And then I'm going to write them out like we did the last time. U, V, V. Over here we have a minus sign now. And then 14 is 2 and 7. And that's U, V. And then the last one is 28. That's 2 and 14. 2 and 7. That's U and V. If we were going to go through this and look at the most restrictive, GCF, for our variables, you see you have a U that has a second power, a U that has a third power, and a U that has the first power. So you know the first power is going to be the one that has the most restriction on it. So that's the one we get to choose. And then we go to V's. We have V to the second power, V to the first power, V to the first power. So it's just going to be V. And then we're going to have to go through and then see what our coefficient would be. We see the only thing in common between all of those is that 7. And so that's the one we're going to be taking out. So 7, 7, 7. So 7 makes its way up front. And then the other ones have the 5. 5's not in all of them. There's a 2 in the last two, but it's not in the first one, so we know we can't use it. And then we can verify like we did on the other one to make sure we got the right variables. You see that you have a U here, a U here, and a U here. That third term doesn't have any more U, so we can't block any more out. We have a V, so we have one V here, we have one V here, we have one V here. And then the last two don't have any more V's, so we can't do any more V's. So we know that we have the correct GCF. So I'm going to write that down here as 7 UV as my GCF. It goes on the outside. And then again, what's left over goes on the inside. So what's left over here is the 5. So we have 5. And then we're left with 1 U and 1 V. So 5 UV minus, go to the next one, the coefficient that's left over is the 2. So 2. And then we're left with 2 U's. So remember when we have two variables being multiplied together, what do? We add the exponents. So 1 plus 1 is 2. Minus, and then we're going to have two variables here, 2 and 2. So 2 times 2 is 4. And then we have no variables left over. Again, we can multiply this out, we can distribute it again, and then see we arrive at the same one, but I'm not going to make you guys do that on this one. That's a good way of verifying you got the correct answer. Okay, again, please message me if you're having some questions on this. I want to make sure we answer them. Okay. Now we're looking at the next one. We're looking for the most restrictive for the variables. So GCF, we see there's one x in the first one, x to the first power, x to the first power, and then there's no x in the last one. So we know our GCF can't have an x in it. And then we go to the y's. We have a y to the 6th, so 6, and then we have 5, 5. Well, the one that is the smallest would be to the 5th, so y to the 5th. And then we've got to figure out those variables, the coefficients, So that's 1 and 7. Here we have 2 and 5. And then here we have 1 and 7. Is there anything that's in common with the coefficients? Well, as we look at that, we see that the only options would be 1 and 7. Well, 10 doesn't have 1 or 7. So we see that it's going to have to be, technically it's just 1. But we can leave it just as y to the 5th. So y to the 5th. And then I'm going to write out those again. X, Y, 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 1, 2, 3, 4, 5, 6. I think I got them. And then it's x to the y, 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 1, 2, 3, 4, 5. And then Y, 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 Y. Sounds like I'm just complaining. Okay, so we're going to get started here. So we see that there's no coefficients for us to steal. But we can look at our y's because the last one doesn't have an x, so we have 1y. We predicted it'd be 5, so 1y, 2y, 3y, 4y, 5y. I can go to the next one and make sure we have 5 y's. 1, 2, 3, 4, 5. That eliminates all of those. And over here, 1, 2, 3, 4, 5. That eliminates all of those. So we see that we did predict the right GCF. There is 5 y's in all of them. And then we remember we do what's left over. Well, we have 1 times 7, which is 7. We have 1 x that's left over, and we have 1 y that's left over. Should put a little plus sign here. So we have this x, we have these 2, and we have that y. Our next one up, we have the 2 and the 5, so 2 times 5 is 10. And what's left over is just going to be the x, and this one's the only thing that wasn't highlighted. And then last but not least, we're going to our final term. It's 1 times 7. 1 times 7 is 7. And then you see there is no variables that have not been highlighted. So this is our final answer. We have what is factored out is that y to the 5th, and then the remaining terms. Okay, again, let me know if you have any questions. Okay, this is our last example. So as we look through this, we want to see if we can figure out our GCF. I look in the first term, we see it's x to the 3rd, and then we want to make sure there's x's in all the other terms. So the next term has a y to the 3rd. It doesn't have any x's. So we know we can't put any variables in this because x's aren't in all of them, and there's no other variable that's in all of them. So then we're going to want to look and see what coefficient we can take out or factor out. So we're going to go here. We have 3 and 21. 21 is 3 and 7. And then we have x, x, x plus, and then 81 is 9 and 9. And then that's 3 and 3, 3 and 3. And then y, y, y minus 54 is going to be 3 and 1, 2, 18. 18 is 3 and 6. 6 is 3 and 2. And then we have y, y minus, we have 36, which is 6 and 6. 2 and 3, 2 and 3. And then we have just x. So we're going to go through and see what we have in common. Right now, it looks like we have a 3 in all of them. So we have a 3 here, a 3 here, a 3 here, and a 3 here. Looks like we have a second 3 in all of them. So we have a 3, a 3, a 3, and then a 3 over here. The only thing left for the variables is a 7, and we see even in the second term there's no more 7s. So we don't have to go any further with the coefficients. And then we're going to look and see the variables. We already decided that doesn't happen. There's x's in the first term, and that's the only variable. So the only one we're going to have to look at in the other terms is if there's x's, and there's not any in the second or third term. So what we're going to do is we're going to take those two numbers we just took out, the 3's. We have 3 times 3, which we know is 9. And then we're going to create what's left over. So the coefficient that's left over here is that 7. So 7 comes out. And then we're left with x times x times x, which is x to the 3rd. Remember, we add those exponents. Here we're left with 3 times 3. Well, 3 times 3 is 9. And then we're left with y plus y plus y. Y times y times y plus 1 plus 1 plus 1, which is y to the 3rd. Over here we're left with a 3 and a 2. 3 times 2 is 6. And then we have y squared. And then we're left with 2 and a 2. So 2 times 2 is 4. And then that x put parentheses around it, and this is how we factor out the greatest common factor. If you look at those terms, there's nothing else left in all of them. So let me know if you guys have questions on this. I'm really happy to answer any of them. I miss you guys. So again, please let me know. Thanks. Bye.